Good morning, everybody. Actually, I tell lies. Good afternoon, isn't it? Right, guys, last naming of organic compounds today. So we're naming esters. Now, I'm going to actually do the naming of polymers when I cover polymers in the lesson next year. So there is one more extra section, but it's just adding the word poly to an alkene, so it's not really very complicated. So I'm just going to finish my organic naming for GCSE now on esters. So I'm going to crack on, guys, today. Let's just get on with this. So learning objectives are up on the YouTube channel, but I will share them and switch over to my clip cam. Otherwise, you just end up looking at my forehead. There we go. Right, and here we go. Okay, so GCSE Organic Lesson 6 esters. Only 2 learning objectives for this, folks. Nice and easy. I need you to understand. Oh, suddenly realized I haven't got my YouTube video up over there. It's going to start shouting at me in it. Come on, come on, come on. That's next year. There we go. So there is one more. There we go. Let's get rid of that. YouTube. There you go. There we go. I'll pop out the chat in case of any questions. There we go. Okay. I'd quite like to maybe try and make my laptop go a bit quicker. Okay. No, it's fine. Okay. Right. 2 learning objectives today, folks. So understand how esters are made. And that's important when it comes to the naming. So that's one of the things that's often forgotten by chemistry teachers, that in reality, you can't just go about naming a complicated family without explaining where the name is derived from. So how do we make an ester? Let's keep this short and sweet today. So making esters. I'll switch to black. I prefer black. Making esters. So in order to make an ester, now just to tell you a little bit about this family. Hey, Jack, it's good to see you. So just to tell you a little bit about this family, we love esters. Esters are a funky family because they have 3 major uses. And you guys see these every single day. So use number 1, I should do this as a nota bene, by the way. Let's switch to red and do it let's make my pen a bit thicker. And then do that. Put this as a nota bene. Nota bene. Why do we love these family? So esters. Yeah. Esters. So esters, it's not too thick. Esters, use number 1. I'll put ester. Ester uses. So number 1, they are artificial smells and flavorings. Artificial smells. So this is perfumes. These are why your perfumes are so expensive. Artificial smells and flavorings. Flavorings. This is in your foods. Number 2, they are solvents. So they're solvents. They actually dissolve plastics. So the example being superglue. Superglue has a very, 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 very sharp, almost burning smell to it. It's because it's an ester and it dissolves plastics. So when the ester evaporates, the plastic solidifies, crystallizes, and forms a solid again. Hence why everything turns solid when you evaporate all the liquid out of superglue. The third one is plasticizers. So what this means is this is actually linked to a solvent, plasticizers. What these do is it softens plastics. So this is how you change PVC plastic from a hard plastic used in pipes into PVC material, which can be used for things like shoes and handbags. So it softens plastics, makes them go soft. So I'll put that in there. So we love esters. Esters are fantastic. Next time you're eating something from a pot noodle to I don't know, anything with a flavor, any form of cake, it will have an ester in it, and you'll usually be able to find it on the back of the packet. So how do we make them, and what do they look like? So an ester is made by taking an alcohol, reacting it with a carboxylic acid. Carboxylic acid, it's reversible, and over the top we have a catalyst. Now we all know that catalysts speed up reactions, and the catalyst is concentrated sulfuric acid. Concentrated sulfuric acid. And I'm actually going to make my arrows a bit bigger now in that case. There we go. And what I'm going to make is an ester and water. Now that arrow means the reaction is reversible. It's nice to have a couple of nota benes here. Number 1, another nota bene. is this arrow here means the reaction is reversible. It means it can go backwards. Yep. Also, I'm going to add another one, catalysts. Catalysts increase the rate of a reaction, increase rate of reaction without being used up. They are amazing things, catalysts, without being used up. Now we're going to see that one reappear. We'll see both of those nota benes will reappear. See later notes from year 11. Yeah, this one will be in equilibrium. This one will appear in equilibrium, and this one will appear in kinetics. Equilibrium, and this one will appear in kinetics. Kinetics. I like it. Both in year 11. So let's now have a look, because the amazing thing about chemistry is the fact that the structures in organic chemistry help you see where things are going. So if we now draw an alcohol, let's keep this super simple. Let's make superglue. Let's make the solvent the superglue. Now, how we do that is I'm going to take an alcohol, which I will draw in green. I'm going to take ethanol. I will also make sure that you guys can see the alcohol group by highlighting it. So here is ethanol, and here is the alcohol group. A couple of you missed the H on the alcohol group during our starter of this lesson. Next thing, I'm going to add to it a carboxylic acid, which I will do in red since it's an acid. Now I'm going to draw it in a rather odd way. I'm going to draw it so that the carboxylic acid group is facing the OH group. There is a reason for this. It's not madness, I promise. I'm suddenly realizing I don't particularly like the size of that writing, so I'm going to thin it down a bit. But I'm making the carboxylic acid group face the alcohol group. There is a reason for this. So this is ethanoic acid. I'm also going to highlight the carboxylic acid group. So the carboxylic acid group, which I will highlight in a pale red, if I can. Highlight it in a pale red, which is all of this bit. I don't like that. I don't like how I've highlighted that there. Rather annoying, actually. What I'll do is I'm going to circle it. This is the carboxylic acid group, and here is the alcohol group, which I'll then put back on. There we go. Right, now what's going to happen here, I'm actually going to take those away now. What's now going to happen is these two groups are going to react together, and they're going to link. Yeah, they're actually going to physically join together. And I'm hoping what you can see is you can see right here, you can see two H's and an O. Yeah, this is water. So during the reaction, water is spat out. And what I'm going to do is I'm going to highlight these of the different colors. The H, by the way, just to let you know, it's actually the O. You don't need to know this, it doesn't actually matter. It's actually the O from the alcohol group that goes, just so you know. But it's nice for me to show you where all these things are going. So there's the alcohol group. Now joined to it is the H from the acid group, and there's my water. Now what's left, now that I've taken away those atoms, a bond is going to get formed between them. And what I now make, which I will draw in purple, I am now going to make an ester. So I'm going to draw the alcohol group first. There's the O from the acid. Let's color code this. There's the O from the acid, and the C double bond O is still there. And then we can link that on to one more H. So we can see that the two things join together. I'm sorry I'm not color coding the H's, I really ought to. So there we go. There's our carboxylic acid. So we form an ester. Here's our ester. Yeah, and here's our water. So we make them from a carboxylic acid and alcohol. Now what I'm going to do is I'm going to now just draw a couple of these to make it a bit clearer for you. So here's the one that we just created. We just created superglue. I'm actually going to draw it the other way around now. So here's the carboxylic acid. You can see the structure of the carboxylic acid here. There's the carboxylic acid structure. Yeah, you can see it in this particular part of the structure. That part there, is all about the carboxylic acid. And what we now have attached to it is this additional chain. And this is now classed as a branch. This structure here is the most important part of an ester. And this part now becomes a branch. This is a branch. Nice. This is a branch, and this is going to be the stem of the structure. So how do you name this? Now, the way that you name this, we always know that the branch, as of last lesson, is a prefix. So the branch is going to be ethyl. This is ethyl. Remember that "yl" means branch in chemistry. There are 2 carbons in this. Yeah, we can see those 2 carbons there, so hence the eth. Yeah, so ethyl, now we go, there's now 2 carbons in this guy. So that's now going to be ethyl F. Now it's got a carbon-carbon single bond. So an ethan O8. And O8 is ester. So this is actually the hardest family to learn to name at GCSE. This is the most complex family. You realize that there's a branch which used to be the alcohol, and the oic acid becomes O8. So now that I've talked through one, let's have a go at another one. Okay, guys, question to the class. Question number 1. Can everyone have a go at naming this one? Off you go, please. Go. Right, winner. There's number 1. Question number 2. On the chat, please, throw up your name when you've got it. Let's go for the next one. How about this guy? Methanoate. Masaru, you've forgotten the branch at the beginning. So Masaru has just given me this part. Meth and O8. But what Masaru has missed is this structure. So can you add that? Thank you, Julie. Julius has now, Julius is now named the second one. I don't know if he meant to, but he has. He's now named question number 2. You need to give question 1 and then followed by your name, folks. Ethyl ethanoate. That was what we had before. Julius, it's not correct for either 1 or 2. Julius, with your responses, please, can you try to put question 1 and then or just Q1 with your name so I know which one you're naming? Yeah, and both of them are wrong. Number 1, methyl ethanoate. No, okay. Methyl is correct. Yeah, methyl, there's the branch. But it's not ethanoate, it's methanoate, because there is only 1 carbon in it. Zyna, Julius has then given me ethyl ethanoate for number 2. Nope, that's not correct. Julius, have another go. Zyna's given me number 2. Zyna, can you please do the same thing when you're answering these? Can you put 1 dot followed by your answer? Number 1, methyl methanoate. Correct, Zyna. Well done. Julius, methyl methanoate. Well done. That's better. Nice fix. Good job. Be nice to have a few more people contributing on the chat here. Let's go for question number 3. Question 3. So, by the way, let's go for these 2 names because I think what I'm trying to do is build strength here. So, the first one, I'm going to do this color coding. Yeah, methyl, because you've got to do the branch first. Methyl. And then going to circle this bit, methanoate. Well done for those guys who got it on the chat. Good job. Masaru, ethyl methanoate. No, you've reversed it, Masaru. The next one is, where's my branch? My branch is the piece after the O. So this becomes a methyl. Yeah, that becomes methyl. And yes, it feels like when you're naming an ester, you often feel like you're naming it backwards because you're naming the branch, which is at the end. So this is methyl, followed by this one, which has 2 carbons in it. 2 carbons. So this is going to be ethanoate. Right. So everyone's had a good go at 1 and 2. Let's try number 3 out. Number 3. So what about this one? What about that? All H's for the rest. What about this one? Don't forget, if you're responding on the chat, put 3 dot followed by the name, please. 3 dot followed by the name. Gayatri, number 1, ethyl methanoate. It's not ethyl, it was a methyl, Gayatri. Thank you very much for having a go there. Well done with the methanoate bit, Gayatri. That's really the most tricky bit. Number 3, propyl ethanoate. Owen, propyl ethanoate. Well done, Julius and Owen. Nailed it. You see, look at that. That's great progress, guys. Well done. Great job. So let's look at how they built it. Now I've got Masaru, propyl ethanoate. Well done. Good job. So once again, let's color code it. Here's my branch. There are 3 carbons in it. This is a prop and it's a branch, so that's an aisle. Next, now I've got this part, and this part has 2 carbons in it. It's an eth, F, and it's a single bond an O8. We're done. Lauren, propyl ethanoate, superb. Callista, well done. Zyna, well done. Good job, girls, well done. Let's go for the next one. Question number 4. Try this one out. You realize that it's just a game. It's all a game. How about that one? And the last 2 I'm going to give you for today are going to be real ones that are used for flavorings. We'll actually look some up. It'll be fun to do so. By the time, so what if we get a branch? Get a branch of a branch. Owen, don't worry, you won't. But it would become 2-methyl ethyl if you had it. I can draw you one if you really want me to. But that you definitely won't have that. There are no branches at GCSE, only at A level. Well done, Masaru. Well done, Owen. Apart from he's got a weird E going in there. You got butyl. Owen, check your name. Callista, well done. Julius, well done. Zyna, Zyna, well done. And Lauren, well done. Good job, guys. You got this now. Figured it out. So we've got a 4-carbon chain over here, which is a branch. That therefore becomes butyl. Isn't it nice doing it via color coding? It doesn't half make a difference to be able to know where the name's coming from. Once again, 4 carbons in the chain. So this is bute. It's an an, so butanoate. We're done. Okay, so let's actually now, just for fun, let's look up some real ones, shall we? So this is where the internet's super useful for me. So what I can do is just grab my keyboard, do the best I can. Let's go for pear flavoring. Let's have a look at this one. So pear flavoring, let's go pear flavoring molecule. Let's go for that. So ethyl decadionate. It's got an E in it. Lol. Let's go for pear drops. That'll be easier. Pear drops, because that's a bit simpler. Let's see if I can find it. Ethyl acetate. Oh, that's interesting. It's not the one I thought it was going to be. That's the same one. This is where you get rubbish on the internet like that. Isoamyl acetate. Wow, giving me the old name. I don't want the old name. I want the new name, please. Really not very useful, that. Pear drops. Let's have a look. Flavorings. It's really not going to be much help to me. Chemical. Oh, all a bit complicated. Actually, you can do this one. There we go. Name it, folks. Oh, it's got a branch on it. Owen, there's your branch. Oh, shame. Such a shame. You do not need to go that far. I don't really want to introduce you to that, really. But it's fine if you want to. Bit frustrating, that. Oh. 3-methyl, 1, 2, 3, butyl ethanoate. That's tricky, that. It's sad the fact that I can't find any simpler ones for you. It's a bit frustrating. Oh. Trying to find simple esters. See, the problem is you guys can't draw them either unless we're on our Google Hangout. So let's go for the last couple. So just to tell you, by the way, that I do know a few, and pair drops is one of them. This is why the internet is a great resource, but it's a bit of a nightmare. So pair drops, this is how I remember pair drops. So we've got pair drops, which is PE. Now this stands for, and I'll draw it for you. Here's pear drops. This is the taste of pear. There you go. Everyone have a go at that one, please. Taste of pear. You can do some amazing things with esters now, make some amazing flavors. Just to point out, by the way, the reason why your perfumes are so expensive and why certain foods are more expensive is because they use a mixture of different esters, and each ester has a different price. So if you use complicated esters which have more complicated flavors, then the cost of your food increases. It's really interesting. So what about that one? Q5. Pentyl ethanoate. Well done, Massaro. Good job. Straight off the bat, he knows his stuff. It's good. I'm very impressed. The next one is apple. So how do I remember apple? I remember apple because of this. I remember these from school. Apple, double P. So this is going to be this one. There you go. That's how I remember them. Isn't it funny? You change the chain length and you change the flavor. It's amazing. Great chemistry. Zyna, your ethanoate, your H and T are reversed. Apart from that, it was all right. Just a typo, probably. This brings me to the end of my lesson, folks. So the first one, pair drops. This is pentyl. It's got a big, long chain here. This is pentyl. Ile means branch, remember. Pentyl, 2 carbons, ethanoate. Ethanoate. And that's pairs. Well done, Owen. Well done, Zyna. Well done, Callista. Good job. And apple is funny because it switches them. So this time you've got a propyl. Propyl and then pentanoate. Well done, guys. Great progress. Really happy with that. There you go. Guys, that brings me to the end of my lesson. You've done great. Well done, Gayatri. Good fix. Well caught. Guys, I'll end my lesson there. This brings us to the end of the name. I will post your booklet of practice questions, guys. I will post the booklet of practice questions. I'm trying to find where my... there we go. So, stop screen. Nice, easy lesson today. It's good. Right. Guys, I'll leave you be. I'll post your practice question booklets because on Tuesday you have a naming test. Yeah, he's going to have some drawing, some naming, some isomerism. All the stuff that we have practiced will be there. You've done great, guys. I'll see you all on Tuesday. Have a nice weekend. Good practicing.